Hello and welcome to today's lesson. Today we're going to be talking about two types of sequences in math called arithmetic and geometric sequences. As you're going through these examples and notes, you're going to want to make sure that you can keep straight what the difference is between the two types of sequences and their formulas. And if you can get that down, that's going to go a long ways to helping these problems be a lot easier for you. So make sure that you're taking those good notes so that this isn't a waste of your time. Make sure everything is nice and neat and not just written randomly across the page. You want to write down the definitions and the formulas and a couple of examples so that you have those to refer back to when you're trying these problems on your own. You can even pause at the beginning of a question, work the question out yourself, and then watch my explanation to see if we get the same answer. And that way you might find some areas where find out you know that area really well, or you might find some areas where you still need to study and work on. And it'll help you to find the best use of your time. So I'm so glad that you are joining us today, and let's go ahead and take some notes.
There are two types of sequences that you're going to see in Algebra 1. One is the arithmetic sequence, and the other one is the geometric sequence. So this slide here, we're going to look at the arithmetic sequence. And that one goes from one term to the next by always adding or subtracting the same value that we call the common difference. So it's a pattern where you add or subtract to get the next number. This can be represented by a linear function, so y equals mx plus b. And the common difference, the number you're adding and subtracting to get to the next number, is the slope of that linear function, so that's m. And so here's an example, 3, 11, 19, 27, 35. Here, they're adding 8 to get to the next number. And here is the generic formula that you might see to represent an arithmetic sequence. To calculate the nth term, so if they want to know what's the 10th term of this sequence, you're first going to take the first term, and then you're going to add that to the term position. So if you want to know the 10th term, you're going to add 10 to it, and take 10 minus 1, and then you're going to multiply that times the common difference. So that would be the number you're adding or subtracting. A geometric sequence is a sequence of numbers when each term after the first is found by multiplying the previous one by a fixed zero number called the common ratio. So this is one where you're multiplying by a number to get to the next number. So if you look at this example, you're multiplying by 2 each time to continue the pattern. A geometric sequence can be represented by an exponential function, and this is the formula you're going to see, where a is the initial value, so the value you're starting with. R is the common ratio, or the growth and decay factor. So here that would be the multiplying by 2, would be 2. And x is the independent variable or term number. So if you're finding the 5th term, that would be x. The first 5 terms of a linear sequence are given below. And here they are. So what is the term of the next sequence? So you just have to find the pattern in this example. So here you're going down, so that means we're either going to be multiplying by a fraction, which could also be dividing for a geometric sequence, or subtracting for a arithmetic sequence. So here, let's try subtracting first. So to go from 101 to 89, you have to subtract 12. To go from 89 to 77, you're also subtracting 12. 77 minus 12 is 65, and 65 minus 12 is also 53. So that means to get to the next term, we're going to take 53 minus 12, which is 41. And that's going to make B my final answer. So here they give us the sequence in table form. And so for the first term here is 0, the second term is -7, the third term is -14, the fourth term is -21, and they want to know what's the 5th term going to be. So I can just look at the pattern in the y column, and I can see that the numbers are getting further from 0, they're getting smaller each time, so I'm going to look at what am I subtracting. To get from 0 to -7, I subtract 7. And to get from -7 to -14, I subtract 7. -14 minus 7 is -21. -21 to minus 7, that's going to be how I get my next term. That's -28, which is going to make C my final answer. This problem says a new company began in January of 2000 with 3 employees. At the end of each year, the number of employees had increased according to the rule below, where n is the number of years after the company began and e sub 0 is 3, so the initial value is 3. Which of the following tables represents the number of employees for the first 4 years of being in business? So for 2000, it tells us they had 3 employees. So that's the initial value, so that's when n is equal to 0. Now to find for 2001 through 4, you're going to be finding when n equals 1, n equals 2, n equals 3, and n equals 4 in this formula up here. So you're going to have 3 times 3 to the first power, 3 times 3 to the second power, and 3 times 3 to the third power, and 3 times 3 to the fourth power. So 3 to the first power is just 3, and 3 times 3 is 9. 3 to the second power is 9, so this is going to be 3 times 9, which is 27. 3 to the cubed is 27. 3 times 27 is 81. 3 to the fourth power is 81, so 3 times 81 is 243. And now we just have to find the table where it matches. So we're looking for a table that has 2000 as with 3, and they all have that. We're looking for one that has 2000 with 9, so that is just A and C. So I'm able to eliminate B and D. And then I want to see, okay, is 2002 27? 2002 is 27, 2002 is 27. 2003 needs to be 81. And C, it's 108. So I can eliminate that one also. And then I'll just check 2004 to make sure I didn't make a mistake. It needs to be 243, which it is. So that means A is going to be my final answer. So this question here gives us a geometric sequence, and it wants to know the first 4 terms. So to find the first 4 terms, that means you're going to find when n is equal to 0. Don't start with 1, you need to start with 0. You need to find when n is equal to 1, when n is equal to 2, and when n is equal to 3. And that's going to give you the first 4 terms. So then you just substitute 0, 1, 2, and 3 for n in this equation. So if I substitute in a 0, that's going to be 2 times 1 over 10 to the 0 power. Substitute in a 1, that's going to be 2 times 1 over 10 to the first power. 2 times 1 over 10 to the second power is n over 2. And to substitute 3, that's going to be 2 times 1 over 10 to the third power. And then we just simplify that. Anything to the 0 power is 1. So 2 times 1 is 2. Anything to the first power is just itself. So this is going to be 2 times 1/10, which is 2 over 10, which simplifies to 1/5. But if I look at my answers here, they're all in decimal form. So that means I'm going to take 1 divided by 5 on the calculator to convert that to a decimal, and 1 divided by 5 is 0.2. So here I have 2 times 1/10 squared. 1/10 squared is 1 over 100. Remember, when you have a fraction, you square the top and you square the bottom. So that's why I got my 1 over 100, which becomes 2 over 100. And since I had to put that in decimal form, I'm just going to take 2 divided by 100 and get 0.02 is what that is as a decimal. And then you're going to have 2 times 1/10 cubed. 1/10 cubed is 1 over 1,000. And when you multiply that, that's 2 over 1,000. And 2 over 1,000 is 0.002, or 2 thousandths, as in decimal form. And so those are going to be the first 4 terms in our sequence, which is going to make choice D our final answer. So here we're given a formula for our arithmetic sequence, -6 plus 12. And it wants to know what is the 8th term in the sequence. So that means I'm going to find it for when n is equal to 8. So I'm just going to substitute in an 8. And work out the problem. So -6 times 8 is -48. -48 plus 12 is -36. I used order of operations to solve that, multiplying before adding, and that's going to make B my final answer. So we have a scientist observes the population of a certain colony of ants increase exponentially each week. This situation can be modeled by the formula below. So this is a geometric sequence. And I want to know, what does 75 represent in the equation? So if you go back to your notes that you should have taken at the beginning of the video, it tells us that that first number is the initial value, 3 is the common ratio, and x is the independent value, or the value, or the number of term you're looking at. So that gives 75 is going to be the initial value, which means that's the initial number of ants in this problem. So that means B is going to be my final answer. Okay, this problem says all points from which the following patterns would be contained on the given graph. And it gives us these patterns down here. And if you remember back to when we took the notes, we talked about the slope being the common difference, being the number that tells us the pattern, how much we are adding or subtracting from each term. So we need to find the slope of this line first. So to find the slope, you can just count the rise of a run between 2 points that cross the grid paper at a corner. So here, I'm counting the rise of a run. I'm going down 1 and to the right 1. And so that's going to be 1 over 1. And this is a downhill line, so it's going to be negative. -1 over 1 is just -1. So here my slope is -1. So that means I'm looking for which one of these patterns is decreasing by 1 each time. So A here is -1, -2, -3, -4. That one I do subtract 1 from both sides. So A is probably going to be my answer. But let's go ahead and check with the other ones. B is 1, 2, 3, 4. There I'm adding 1 to do that pattern. That's not subtracting 1. So it can't be B. C, I'm going -2, -4, -6, -8. There, I'm going down by 2, so that's subtracting 2, not subtracting 1. So it can't be B or C. And then D, I am -3, -6, -9, -12. So I'm decreasing by 3 each time. That's not subtracting by 1, so it can't be D either, so that makes A my final answer for sure. This problem here says Alice started a new job at an annual salary of $29,000. The company offers a 4% annual raise. Approximately what will be Alice's salary at the time of her start of the 4th year? So if you remember back from our notes on geometric sequences, if it's being raised by 4% each year, and that's going to be a geometric sequence because you're going to be multiplying by 4% each year. So to write a formula, I just went ahead and copied down those notes that tell us what the formula is and what is each part represents. So here, A is that first term. So that's her starting salary. So $29,000 is going to be our A. And then B is the common ratio. So she's going to get what she made the year before plus another 4%. So she's really making, each year, she's making 104% what she made the year before. So if you just did the 4%, you're just getting the raise part. The 104% is the raise plus what she made last year. So that as a decimal is going to be 1.04. And that's going to be raised to the x, which remember the independent variable, remember x equals 0 is the first term. So that would give you the 29,000. So to get the fourth year, you're going to actually be looking at x equals 3. So that's going to be raised to the third power. And then you just have to work that out. So you're going to do exponents before multiplication. So 1.04 to the cubed is 1.124864. And that's going to be multiplied times 29,000. And when you do that multiplication, it rounds out to 32.621, or comma 621, sorry. And that is choice B. Here, Carlton has a new job. His salary for the first year is $20,000. He receives a raise of $600 every year. Let Y represent his salary after X years. So which does the given description represent, an arithmetic or a geometric sequence? So each year he's getting an additional $600. So that means you're adding $600 onto his salary every year. So the second year he would make $20,600. The next year he would make $21,200. So you're adding $600 each year. So since it's an adding or subtracting pattern, that's going to be an arithmetic sequence. So I'm going to go ahead and cross out B and C because it can't be a geometric sequence. And so I look at the difference between the answers A and D. And here the difference is that A says it has a common ratio of 600, and D says it has a common difference of 600. If you go back to the definitions that we took in our notes at the beginning, a common ratio is what a geometric sequence has. A common difference is the vocabulary word to describe the pattern for the arithmetic sequence. So because a common ratio doesn't go with an arithmetic sequence, it can't be A. That means D has to be my final answer. Okay, this example says, determine whether the graph below represents an arithmetic or geometric sequence. When looking at this graph, and it's not a straight line. Remember, arithmetic sequences are straight lines, so it can't be an arithmetic sequence. It has to be a geometric sequence. And geometric sequences are often exponential functions. So, and this is the shape of an exponential graph. So it makes sense that this is going to be a geometric sequence. So that means I can go ahead and cross out A and C because they have the part of their answer is saying it's an arithmetic sequence, which it isn't. So that just leaves B and D. And then B and D, I look at the differences there, and B talks about a common ratio, and D talks about a common difference. If you go back to your notes, a geometric sequence is the one that has the common ratio. It has that number that you multiply by each time to get the next number in the pattern. So it can't be the common difference because that goes against the definition of geometric sequences. So it can't be D. That means it has to be B. Number 11 gives you this formula, this equation. It wants to know, is it an arithmetic or geometric sequence? Well, looking at my notes, for the formulas for arithmetic and geometric sequences, the x is in the exponent for a geometric. And the arithmetic notes say that it's going to be a linear function, like y equals mx plus b. This is in the form y equals mx plus b. So that means it's going to be an arithmetic function. So that means it can't be geometric, so it can't be A or C as my answer. And once again, I look at the differences. B talks about a common ratio. D talks about a common difference. Common ratio goes with geometric sequence. Common difference goes with arithmetic sequence. That means D is going to be my final answer. So here you're going to determine if the given sequence is linear, exponential, or neither. If it's linear, that means it's an arithmetic sequence. You're adding or subtracting by a certain number to get the pattern. Exponential is a geometric sequence, and you're multiplying or dividing by the same number to get the pattern. So if I look here, I can see, well, 5 to get to negative 25 would be subtracting 30. If I subtract negative 25 minus 30, that's going to be negative 55, not a positive 125. So it's not going to be linear. So now I have to see if there's a number I can multiply by to get each term. So 5 times negative 5 is going to give us negative 25. See if it holds up. Negative 25 times negative 5 is positive 125. Positive 125 times negative 5 is negative 625. And then last, negative 625 times that negative 5 is 3,125. So you are multiplying by a number, the same number each time. So that's going to make this problem exponential and make C my final answer. This last problem, once again, we're asked to determine if a given sequence is linear, exponential, or neither. So remember from our notes that a linear function is going to be an arithmetic sequence, and an exponential function is going to be a geometric sequence. So that means for the linear, I'm looking for to see if there's a pattern where I'm adding or subtracting by the same number for all of these terms. And for exponential, I'm looking to see if I'm multiplying or dividing by the same number for all the terms. And so let's go ahead and start with subtracting. We're adding the linear one. And I'm looking here at negative 28 to negative 8.9. That's increasing, so it's going to be adding. And so if I add 19.1 to negative 28, that gets me to negative 8.9. So let's check it out. Negative 8.9 plus 19.1 is 10.2. And you can use a calculator to check this also. 10.2 plus 19.1 is 29.3. And then last, 29.3 plus 19.1 is 48.4 also. So that means that one is going to be a linear function because the pattern is adding by the same number each time. So my final answer is going to be A. Thank you for joining us today, and I hope you learned something new.